Unknown current practice problem number 1. At 9:47, your position is latitude 4115.9, longitude 7141.7. You are on course 182 per magnetic compass at 11.3 knots. At 10:20, your position is 41092, longitude 7140.6. What were the set and drift? So, what we're going to do, we're going to find this position started, the position you ended, the course you think you're traveling, and how far down that course, and then we'll get the set and drift from there. So, to find the starting position, 4115.9, 4115.9, and 7141.7, 41.7. We're going to be right in here somewhere. So, here we go. 15.9. And 41.7. 7141.7. It's our start. Let's find our ending point. 41092, 41092, 09.2, and 7140.6, 7140.6, 7140.6. Let's check. 41092, 41092, 40.6. Over here, get our 0.6. So these problems is really important, very important, to get the starting point right, the ending point right, and then to plot your course correctly. If you don't do those 3 things correctly, you can't get the problem right. So whenever I'm looking over these problems, I do the same sequence. I go to the start, I go to the end, and I make sure they plot their course correctly. And then, if those are correct, it's just a matter of a couple numbers. So, 40.6. Good. So here's the end. Here's the start. And now it says we were on a course, right? We were on course 182 PSC. Well, we need to put it on the chart. And this is in degrees true. So we need that PSC into degrees true. T, V, M, D, C. 182 down here. 182 degrees PSC. Deviation from our table for 180 is 2 west. 2 west. When we're going up, we subtract. So 180 magnetic. Variation 15 west on Block Island. Subtract it because we're going up. So we get 165. 165 degrees true. 165, 75, 180. Right. 70, 180. Good. These are important. So that's our course true. Get it on. We'll get it off of our compass rose. And on the chart. So 165. A little cluttered here. There it is. 165 from our start position. and draw a little ways past the ending point. Okay. There we go. So, we were intending to take this DR course, this Dead Reckoning course, but we actually ended up here. So a current pushed us over to where we ended. Good. So we got our start point correct, our end point correct. We plotted our corrected course correctly. Now we need to figure out how far down this course we should go. So we got some D Street to do. Distance, speed, time. It says our speed was 11.3 knots, nautical miles per hour. Then it gives us two times, so we can find a time, right? 9:47 and 10:20. So 10:20 minus 9:47. 10:20 minus 9:47. Okay, I'm going to do a bit of this in my head, right? 13 gets to 10 plus 20 is 33 minutes. 33 minutes. In order to put it here, we need it in hours, right? Let's make sure. 33 minutes. So 9:47 to 10 is 13 minutes, and another 20 minutes to 10:20 is 33 minutes. So 33 minutes divided by 60 is equal to something. It's 0.55, I'm pretty sure. Let's check it on a calculator. 33 divided by 60 equals 0.55 hours. So now we have a time, 0.55 hours. So distance equals speed times time. Speed times time. Our speed, 11.3 nautical miles per hour times 0.55 hours gives us what? 11.3 times 0.55 equals 6.215. So 6.22. 6.2. That's what I'm going to call it. Nautical miles. That's how far we should have traveled. If we were going 11.3 knots for 0.55 hours, we should travel 6.2 nautical miles down this line. 6.2. All right, from the start, down 6.2. Okay, this is where we reckon we should be. This is our dead reckoning line. It's where we reckon we should be. We ended up here. So a current pushed us this way. So now all we need to do is find the set and drift. All right. Okay, the current pushed us this way, so we go from the center toward where the current pushed us. From the center. This looks like 2224. So we got a set of 224 and our drift. So we got this distance. And we got pushed this distance in a time to get a speed, right? This distance is 1.1. So we need to do another D Street problem. Distance, speed, time. Our distance, we said, was 1.1 nautical miles. We're looking for a speed, which is drift. Our time is the same time. We got pushed that far in 0.55 hours. Speed, right? D Street. Speed is equal to distance over time. distance over time. 1.1 nautical miles in 0.55 hours equals 1.1 divided by 0.55 equals 2. 2 nautical miles per hour. So our drift is equal to 2 knots. Now let's check out the answers. So we have 111 at 1. Here's 229 at 2 knots. And we got 224 at 2 knots. And the others are reciprocals, 58 and 43. What's cool about these problems is if you read the correct side of the compass, you're down to 2 answers to choose from, because the other 2 are always reciprocals. People read the other side of the compass a lot in these problems. So set 224, drift 2 knots, and right now here we have B, 229 at 2 knots. Generally, your drift is going to be closer than your sets. When you're trying to measure the angle of 2 dots, let's say try to figure out the angle of these 2 dots that are really close together, I have a lot of error. When I'm trying to line these up, I can put a lot of error in there and still be on the dots. Whereas if I'm trying to walk these 2 dots over, I get almost no error. So when you're measuring these sets, you end up with some error, and the drift is a bit closer. So the correct answer should be B, and it is B.